This is the video following the part 2 video where I cleaned and washed this Musical Fidelity P180A integrated amplifier. When I first got this amplifier, I did an initial test and I found a fault in the power supply where there was some fractured diodes. I was lucky to have found a problem in the power supply, that it was one of the secondary wires that came loose from the star point connection in the amplifier, and that I assume caused the diode bridge to fail, and in event after that caused the amplifier to lose the positive rail on the left channel. But so I luckily got that sorted, because at first, when I initially didn't get a reading on the positive side of the left channel power supply, I thought this transformer might have been faulty. Now you would notice that some of you would, some of you won't, but this is an aftermarket power supply. I want to assume that the original power supply for this P180A was a single transformer, single capacitor bank affair with a single cable. But this is clearly an aftermarket power supply, because these transformers were made by a place called Gardner & Son in Johannesburg. And these toroids are rated at, let me just see, at 625 volt amperes, which is quite hefty for an amplifier that I estimate is around about 90 watts per channel. But that's fantastic. Super overkill. And then the original power supply input for this amplifier was in this position, but an additional cable has been installed this side, so each channel is fed by its own transformer, rectifier, capacitor arrangement. After I got this amplifier, I immediately did a basic test to just make sure that it's viable to to invest time and energy into this amplifier, and then of course also making this video. So apart from the power supply, where I had a failed positive supply for the left channel, and that being very evident by this burnt power supply resistor, and just focus there. The positive rail being down caused a couple of other issues as well. Just steady the camera. When I replaced the resistor and I got this channel playing, I then, not long after that, had a failure of this little power supply or power regulator cluster that supplies the 12 volt positive rail for the driver stage and the op amp. And it's made up of a TIP32C and a BC550C. And that baffled me for a moment, because I really could not take the amplifier over 6 volts per rail without this set of components heating up at an alarming rate. And I started looking everywhere. Also, another thing that prompted me to look for the problem was that I got an unequal drive. The output of the op amp feeds the bases of these two transistors, and then obviously it cascades to the final pair of transistors that drives the J50 and K135s. This is a BC550 and a BC560 that does the driver work. On the transistor here on the negative cycle side, I've got a beautiful drive signal. Symmetrical, lovely, everything you want. But on this side it was severely clipped, and I thought to myself, maybe we've got some blown transistors, so I took all the transistors out and I put them through the little transistor tester, and they all checked out perfectly fine. And then I noticed that the op amp on this side only gets 3.5 volts, where this side gets about 12.1, 12.2 negative volts. And that prompted me then to check a couple of resistors. They all checked out fine. I then moved to this tantalum capacitor that sits at the anode of that Zener diode. It also checked out fine, and eventually I just for, you know, as a last scenario, I swapped around the Zeners from the two channels, and the problem all of a sudden went that side. So the problem was clearly that Zener diode that failed, yet that Zener diode tested fine outside of the circuit. Well, tested fine relatively, you know, I didn't have any reason to suspect it being faulty. But it ended up being the other major fault in this amplifier. So I replaced that with a fresh 12 volt Zener diode, and the amplifier is happy. It's playing well, it's sounding great. It's clearly a high-level Class AB amplifier, probably fringing on Class A, because these transistors put out a huge amount of thermal heat. Yeah, so classical musical fidelity design. This is just just marvelous. So yes, that's where we are now in terms of fault finding and testing. Is that I'm confident that the electronic issues with this amplifier has been sorted out. The next step is going to be, whoops, not to kick the stand. The next step is going to be to get the control knobs replated with gold. Hopefully that won't cost an arm and a leg. And I'd very much like in one of the videos I said I'd explain about this switch here, which is a double pole single throw rotary switch, and the wires are cut off. Now these wires probably went to the original power supply to switch the whole system on and off, and I'd like to get some form of a control back on this switch. So one way I'm thinking of doing that is to either get a multi-core cable that can carry these control wires to the power supply and either switch a relay or the mains directly, or whatever's going to be safest and most reliable. Or I then just install a 4-pin connector, so you'll have 3 cables running to the power supply. That's one thing I want to get sorted, so that works. And then I'm going to replace all the 0.22 resistors with modern wire wound types, so that I know that that's happy and sorted. And in terms of the power supply, let me just swing the camera over there, stabilize it. The challenge with the power supply is going to be to get an enclosure made to match the dimensions and the aesthetics of the actual amplifier module. So same with steel enclosure at the back, and same style faceplate in the front, and then also if it's not going to be too dear to get that faceplate, also chrome plated, so that you have a nice matching set. And that will conclude the journey of this Musical Fidelity amplifier. Thank you.